ahead and go over Chapter 9, Test Review. I know that I want to go over the how to do the graphs for sure. Make sure that on your test that you are going to do this and draw in that dotted line for the asymptote. Some of the people in my first period class did not do that, and I had to go back and take a look at, or remind them to do that. Okay, so if we're going to graph a log, that's more challenging than graphing just the exponential version. So we want to graph exponential partner or cousin or whatever first. So here's what happens. If we say y equals log base 2 of x, rewrite that. What is that as an exponential function? Well, actually 2 to the y equals x. Okay? But we want to actually make a table of its inverse. It is simpler to make a table of its inverse. And what is its inverse? Good. 2 to the x equals y. Okay, so 2 to the x equals y. So then we'll make a table of that. All right, and I want you to have at least 2 points. I do not want just like something kind of resembling a log graph on there. I want exact points plotted. Okay, so 0 and 1, and then, so this would mean 2 to the 0 is 1, and 2 to the 1 is 2. Okay, so that's the inverse table. But how do I get back to the logs table? Switch it.
I think 2 to the y equals x.
I could have. I mean, some people can just do 2 to the y equals x and make a table from that. Okay? So this would be 1, 0, and 2, 1. All right, so now I have 2 points that I can plot, and I'm going to put those on there. 1, 0, 2, 1. I know that my asymptote, I'm going to draw a line from asymptote at 0, so this is looking like this. Okay, what's my domain? Okay. Range, negative infinity to infinity. Asymptote, x equals 0. Do not just say 0. Do not say y equals 0. It's x equals 0. Okay. So, what is the second one doing? Shifting up. That's a k value, so we take that first one and shift it up 3. I'm just going to take those points, shift them up. And I know it's still going to have the same asymptote. Domain, same. Range, negative infinity to infinity. And the asymptote, x equals 0. All right, what does number 3 do? Left 3. So I'm going to take those original points and go left 3. So where's that going to put my asymptote? At negative 3. So what does that make my domain? Negative 3 to infinity. Range. Asymptote. What? X equals negative 3. Not just negative 3. Not y equals negative 3. X equals negative 3. Okay. Next section. This is still going to be on the non-calculator part of the test. You're going to be doing these functions without a calculator. So 3 is your base to the negative 2 equals x. Got questions on how do you do that without a calculator? First period. Well, what's the negative? Let's address the negative exponent. What's that do? Good. It's going to reciprocate this base. And then just what's 1/3 squared? 1/9. Okay. So there we go for that. Here, this is saying what to the 4th power equals 16. And if you know your 2's, it's 2. Since 2 to the 4th power equals 16, W is 2. Here, this is saying 8 to what power is 0. And what do you know if you have a 0 or a negative within the log? Okay, no solution. Not possible. Here, 2 to what power is 64? 6. Okay, what's 8 saying? Understood base 10 to the negative 3 equals W. And so what is 10 to the negative 3? It's 0.001, or you could write it as 1 over 1,000. Either one of those would be an acceptable answer for W. And this last one, 2 to what power is 1/4? How do I get this whole number to reciprocate? A negative exponent. And so what's my exponent going to be? Negative 2. All right, questions there on that section. Next. Okay. This is the thing that I'm most worried about, especially on these problems where this condensing is involved. Those are the ones that I didn't like, for instance, number 10 and number 13. Particularly number 10, because we still have a tendency, I even got this morning. Somebody came in and I saw somebody go, 2 times x plus 3 minus x plus 1 equals, we did get that. Okay, no, that is not the correct process of those logs. Okay, so, that could have been a common mistake that other people would have seen also, so I wanted to point that out. You have to condense this left side before you can set those logs equal and then just set those inner terms equal. You have to have a single log on both sides. So how do I condense that left side? Yes, this 2 becomes the square to that x plus 3. And if these logs are subtracting, then what? It's dividing. So here's what I have. I still have a log right now. Log base 3 of x plus 3 squared divided by x plus 1. That's all what's inside the log, equaling log base 3 of 2 cubed. Yes?
Could you move the main log to the other side and also condense it on the other side?
Yes, that's a good question. The question was, could you move this negative log over to the other side and then condense it on the other side? Yes, you could do that. That works. Okay. Now, here's what I saw people asking me when they were taking quiz 9-4. They were, at this point, wanting to multiply by x plus 1 so they could cancel those out, okay? And then multiply by x plus 1. No, you have not gotten rid of the log yet, so you cannot start simplifying yet. You have to get rid of the log first. Okay, so now that I just have a single log on the left and a single log on the right, now I can raise those up and get rid of them. So what that leaves me with is x plus 3 squared divided by x plus 1 equals 8. I got 8 because that's 2 cubed. Okay, so now what? Simplify by doing what? Okay, multiply by x plus 1. Those cancel. And I've got this x plus 3 squared. Okay, you're going to have to FOIL that. Please tell me you can FOIL that in your head by now. X plus 3 times x plus 3 is going to be how much? plus 6x plus 9 equals 8x plus 8. Okay, I'm not finishing it out from there. From there, you get a quadratic. That's Algebra 1 stuff, majorly Algebra 1. So you end up getting just 1 as the answer. And then you have to go back. Do you have to check it on this one? Why do you have to check it? Yes, you have to check it because it's in the log. Because the variable is within the log. So if I put 1 in here, I get positive. If I put 1 in here, I get positive. I'm all good. So 1 is fine and acceptable. Okay. 11 is not such a big deal. How do we do that? Log both sides. My log both sides. That's x log 3 equals log 14. Divide by log 3, and then you get 2.4022. You know, I did rounding. I don't know exactly if I rounded within it or just put that in that way. But if you are just a little bit like a thousandths off or such, then that's fine. 2.4022. Okay, 12. How about that one? We're going to do what to bring those down? Log both sides. Okay, I'll go ahead and go over this one because I see a common mistake or a common question that I keep getting asked. Okay, what's the best way to start simplifying this? Divide away from this 3x plus 1. Divide away from this 3x plus 1. So divide by log 2. I'm dividing away from the 2 terms over here to the one with the 1 term. So then I get 3x plus 1 is equaling, and this is just a number. And what number is that? I got 2.322x. Okay, so you have 2.332x's. That's the coefficient to the x's. Now, collect your x's together. So I then subtracted 3x. And that gave me negative 0.6781 x's. Divide by negative 0.6781 on both sides. And that's how I get my answer, which is negative 1.4747. Okay, questions there?
Can you have a negative number?
Good question. Question is, can you have a negative number? Okay, where is our variable and the exponent? So you can, because it's an exponential function. What's the domain of an exponential function? Negative infinity to infinity. So negative's okay, and an exponent. Okay. Yes, it could be a 0. Yep. Domain is from domain of exponential is negative infinity to infinity. So anything that's real, including 0, is all okay. All right. All it would do is that 0 would be making it, it'd be right there on the exponential function. Okay, so it's real. All right. Do I need to do 13? Okay, yes, I'll do 13, but then I'll kind of stop doing some other things, and I'll just give you some answers to check. Here we go, 13. What do I need to do first? Okay, good. Vocabulary, correct vocabulary there, condense the logs. I'm going to condense them first. Condense these into a single log. Log base 5, and because they are adding, then what will they do within the log? Multiply. Okay, this is a common place that we get stuck. How do you get out of a single log? Good, write it in exponential form. So this in exponential form is going to be 5 to the first power equals this x plus 1 times x minus 3. So that's how you get out of a single log. All right, and then from there you can solve it. You get two answers, which are 4 and -2 once you end up solving this quadratic. And then because my variables are within the log, I gotta go check them. 4 is all good, gives me positive, so 4 is good. -2 would give me a negative here on the left, so I already know that's going to be no, that's extraneous solution. Okay, 14 is going to be the same, it's just more practice of it. I will tell you the answers. You end up getting -6 and 3, and this -6 ends up being extraneous. Number 16, what's the one thing you need to make sure you do first? No, do not natural log right now. Good. First divide by 16. You cannot natural log yet because, why? Why can you not natural log from the get-go on this one? Why?
16.
The 16 is requires
The 16 is not being raised to that exponent. So you have to isolate the term that has the exponent before you take the log. Okay, so the answer there on 15 ended up being 0.2528. All right. Next.
what?
Practice. More practice. Okay, so let me just give you these answers. Then you can ask me if you have any questions on that. Number 16, T was -0.125. 17, X was 1.7105. 18,
But on number 16, would it be no solution?
okay, this is a good question. The question is on 16, would it be no solution? Okay, well, let's go check it. Here we go. If I go put this negative,
I got it perfect.
if I get -0.125, okay, well, that's the number you should have gotten. But if I get -0.125 and I put that in here, let's think. 2 times -0.125 plus 4. Guess what that ends up being? So that ends up being 3.75. So that's positive. So it's okay there. If I put it within this one, 3 times -0.125 plus 1, that ends up being 0.625, which is positive. Okay, so that's an interesting point to make. The answer is negative and is okay. All right, questions there? All right, 18. The answer was -1.6967. Number 19, X is 0.8196. Okay. You got up to 2x plus 1 equals ln 14. Then this is a number. You know, so you can type this into your calculator because these problems are on the calculator section of the test. So you would get this number and then subtract 1 from it and then divide it by 2.
Where'd you get 14?
Because he added 3 and then divided by 4. Okay, and that's how he got that 14, and then he took the natural log. What?
It would be no solution if you plug it into the...
Okay. The question is 18 no solution? Because when you plug it in, you get something negative. What type of, where's the variable? Variable's in the exponent. So exponential functions can have a negative up there. You only have to check if the variable's in the log. Okay, good question. All right, number 20. These were pretty straightforward plugging in. Can I just give you the answers here? So we got 6344.93. Number 21. one was 5,000. 1 plus 0.06 divided by 4 to the 4 times 4. Okay, so then I would calculate it by going, okay, 5,000, and what's this? 1.15, 015, okay, to the 16. So I would need to make sure that when I calculate it, that I'm doing the exponential part first. This I get people making mistakes on. Calculate the exponential part first to the 16th power, and then multiply that by 5,000. Okay? Do not make the mistake of multiplying first and then taking exponents. I mean, hello, when did we learn PEMDAS? Okay? Exponents before multiplication. At least 6th grade. Okay, not to make you feel bad or anything, but please make sure, I mean, that is a common mistake, so please do make sure that you do the exponents before multiplying. 21. 7.3188 years. That's the answer. Next, 22. 3188. Okay, that's all right. A little bit of the decimals being off is fine. That means you might have kept the entire value and I rounded to 4 places within my problem. And so that could be why actually yours is even more accurate than mine. 10.8125 years. Here was 8.7455 years. And then the last one was more graphs. Questions on doing that. What are you going to do first? Make the exponent. The inverse, good. Graph the inverse, which would be this one. Okay, so it goes through 1, 0, and 3, 1, and so on. Which way would number 25 shift it? Down 2. And which way would number 26 shift it? Right 1. Does your asymptote change on number 25? Shifting it up would still give it an asymptote at 0. Shifting it right would make the asymptote at 1, and the domain would have been changed. Yeah, that was, I think it's totally wrong, but anyway. Okay. That's it.